It's a really easy question.
I think what we're talking about is what's at the very edge.
Hello and welcome to the Edge Tech Podcast, where technology meets the edge of innovation. I'm David Kosloski. Today we're talking about edge technology and Internet of Things, or IoT. Alongside me today is Ed Barkhuysen, who is the VP of Product at Simply NUC, and next to him is Ryan McAnlis, who is another visitor we've had multiple times, who is the CRO, Chief Revenue Officer at Simply NUC. Guys, simple question, IoT, edge computing. Explain this process of deployment for IoT and how edge computing benefits it.
Well, that's easy.
Yeah, it's super easy. It's a really easy question.
Well, for me, IoT is really the deployment of devices way out right at the very edge, right? Where each device is connected, is able to be enabled with sensors so it can interact and monitor its environment and share that data back. So centrally, you're able to see what's happening and able to make decisions based on that or control these devices and enable them to remotely perform activities or actions that's going to benefit you or your company or customers. So yeah, it's that device compute way out there at the edge. And I think there's lots of opportunities to then interact with that and bring that together at a higher level of compute as well.
And how does it enhance, I guess, the IoT system? So explain that process.
So IoT, Internet of Things, is a term that I first heard probably in 2007. And it's had a number of kind of false dawns probably of being able to deliver exponential value to the enterprise. I think there's been some of that, but it's never quite fulfilled its potential of a $70 trillion market opportunity in terms of devices and infrastructure and connectivity and revenue generating opportunities from that. What the evolution of the compute at the edge in 2024 and beyond gives IoT is the ability to have powerful compute or silicon everywhere because of the cost factor of the compute, because of the form factor of the compute, and because of the connectivity of the compute. That means that no longer are we doing an Internet of Things or an Internet of Everything, which is a kind of binary decision. A sensor might be saying yes or no. Now a sensor can say a lot more about what's happening in industrial manufacturing, in agriculture, in logistics, in wherever it might be. So the Internet of Things has evolved massively because of edge computing due to the evolving technology, the cost, and the form factor of that technology.
So you mentioned that 70 trillion and that it didn't fulfill its full venture. Why is that?
I think that for me the technology wasn't quite there in for the enterprise to be able to invest to get that return on investment. So if a industrial manufacturer wanted to connect everything in terms of the process of manufacturing aircraft wings, for example, the cost of doing that versus the benefit and the return on that investment was up until now, I think, too expensive. So it's gotta have a return value quickly for the financial decision makers to be able to say, yes, we should do that. And also then from the technology decision maker point of view, is connecting the devices with the technology that we have, giving us the valuable data analysis to be able to make informed decisions that actually have an impact on the process. And for me, up until now, that's worked in some areas, but not others.
Yeah. What do you think, Ed? Do you agree?
Well, I think one reason perhaps it's been held back slightly is there's also a lack of standards. So there's many different competing standards. And I think there's an opportunity, and we're seeing them converge. So we are seeing the devices being able to interoperate a lot more so than they have been historically. And as we see that convergence of standards, we probably see a much quicker adoption and rise of Internet of Things and edge devices that are supporting us in many ways. And in many ways we're not so familiar. So as a you can be on your way home and turn your heating on before you arrive, so your house is nice and warm. that's something that you're very aware of and you're in control of. But there are many things around you on your way home that you may not be aware are occurring all around you. So as you're driving down the street, there's devices that are monitoring the traffic flow around you, and helping route you via traffic light systems and traffic management systems to get you home safely, but also most efficiently as well. All that stuff you're not aware of. So this is happening all around us and in the background. And I think as we see convergence there, yeah, absolutely, we're gonna continue to see that improve and enrich our lives as individuals, but also have operational efficiency for many customers as well, and many organizations, which will end up in resulting in that revenue stream, which makes it really obvious to continue that investment.
Did IoT always work with edge computing? Like, was it when we rolled out IoT devices and this on-off switch example that you gave, was edge computing always there, or was it something that was later adopted?
Well, as far as silicon's always been there, or compute power's always been there. It's always lived at the edge. Edge computing lives where humans live, and compute has always lived. Ed will be able to do a much better history of computing than I will, but compute power has always lived where humans live, and I think more and more so, we want the compute to live where decisions happen, where humans interact, where business takes place, and that gives us more data. The thing I was saying before, more data analysis, more information, and the ability to make quicker decisions that impact our lives. I love the example Ed gives there about the home. It's a really easy way of understanding IoT. We've smart lights or smart meter technology's been around for quite a while, but connecting this under the one standard, we've got competing software platforms that drive your home, and some people are either Google or some people are Apple, and managing your home in those two ways means that you might, if somebody's got both of those, which way do they go? So we can see smart locks and smart doorbells, and everything is becoming more and more connected in the home to our benefit, but it has taken quite a long time.
Right.
As we look at all of the devices that are out there, and there's varying levels of compute. So as Ryan mentioned, historically, the level of compute at the edge versus being centralized in perhaps a data center has been cyclical, and it is swung either way, every few years for probably the last 30 years. And the primary reasons for that, right, is the ability to have the level of compute that's required, and the connectivity to then go and make best use of that. And as connectivity is improved, and what we're seeing right now with 5G and mobile connectivity, that's going to be another driving factor, which is going to enable that compute to be delivered at the edge, but also the value then derived from that. Yep.
Sure. And are there any, we've touched on a lot of examples before, but I mean, what are some examples that we haven't touched on where IoT is an application where IoT is powered by edge devices?
An application where IoT is powered by edge devices? Well, almost everywhere.
Well, I quite like I'll say, for example, on a car manufacturing line, as a car moves through that line and goes through all different stages of being built, there's lots of sensors around there monitoring, hey, is from a quality assurance point of view, are we able to predict that there's going to be perhaps a failure on that line in advance and get ahead of that? But also monitoring, for example, the paint levels in the spray guns as they move down that line. So that there's a centralized edge, high level of compute that's making use of all those sensors, and then real time able to ensure that line stays up and stable, and that a lot of the risks are mitigated from that line going down. Because every minute that line is down, you're talking thousands, if not potentially millions of dollars, depending on that line. So having that ability to have edge compute with real time and potential autonomy in there as well, where a connection back to the cloud is not needed. It's able to make use of a local large language model to then ensure that line is up. Yeah, there's huge value there.
Yeah. And then speaking of the real time, and when it comes to latency, previously, or let's say edge computing is not necessarily, or there's not an edge device that is there, what does that latency usually look like in this particular situation?
Where you have your edge compute localized, I mean, milliseconds. The latency isn't a question in that scenario.
Gotcha.
Yeah.
And then the alternative is seconds.
Potentially, but also there's the risk that you're not in control of that connection from endpoint to endpoint. So that could even go down, and that could be outside of your control completely. Do you want your business to be reliant on a connection which you are not able to control? A lot of businesses want to be able to ensure that they're in control of their uptime, and that's really important. Therefore, to have edge compute localized.
Yeah, and when you're talking about the IoT, like there's multiple sensors in like this automotive concept. Does each IoT device require or need an edge device, or is it possible that the one edge device controls a multitude of IoT devices?
It depends.
Yeah.
Is the answer. So multiple sensors can connect to one compute device. It depends on the scenario of the requirement for that sensor to deliver compute. So, for example, in machine vision, if there is cameras analyzing what's happening on a manufacturing line, quite often that compute power required is either going to be done at the camera if the edge device is living there, or it'll be done in the cloud. But it's unlikely that in a machine vision example, you'll have hundreds of cameras connected to one device. That's probably going to be too much compute power required for that device.
Does that change the construct of terminology in the sense that if the edge device is connected to the camera, would the camera be the IoT, or now has the edge device become the IoT?
It's everything. So the Internet of Things is all of the connected devices.
It's the whole concept of it.
Yeah.
Interesting.
Yeah.
Fair enough. Cool. Dumb question. Don't add that one.
I think it's a good question.
Yeah.
And I think it's an obvious example of perhaps where, we spoke about turning or heating on in your home. But what if you had a smart home where it was monitoring, hey, which rooms are in use? Where's the sun at? Which blinds do we need to open and close? And where do we need to route the air conditioning in that home? That's when it brings it all together. And I think that's where you have a centralized control system with an increased level of compute that's going to add a lot more value than independent sensors operating independently.
Interesting. So that in the home example, from a consumer perspective, just out of curiosity, where does edge computing, like, is it telling me how much I'm saving in energy or what have you? Like, is there anything from a consumer level that benefits me?
Yeah. So the home is a great example of Internet of Things and edge compute. For example, power required in a home now can be supplied from many different directions. So it could be on grid or off grid. It could be a combination of both. It could be solar stored in batteries, power from the batteries in your car, and the compute in the vehicle, in the solar panel infrastructure, in the device that manages the temperature. All of those devices will have some level of compute, and there's sensors in those. So in a lot of homes now, there's probably more compute than people realize, and in all of those homes, as people invest in technology, whether it's a kitchen appliance or it might be in your entertainment infrastructure, or it might be in power and cooling or security. More and more, all of these things are going to be connected. So there's sensors and compute in all of this technology.
Yeah. When you mentioned security, and it's not necessarily related, but there's benefits that we hear about edge computing and security, and we've touched on them. But what's the biggest benefit, Ed?
From a security point of view. So I think a lot of the sensors around us, enrich our lives, but many people are cautious about them as well. So from a security and point of view, there's the legislative angle, which you need to look at, GDPR, Data Protection Act here within the European Union, which are being broadly adopted globally. So making sure that you're compliant with those. So if you've got a camera in a shopping center, that you're not capturing people's faces, and they also, from a personal point of view, they're not worried or concerned that, hey, I'm being tracked and monitored. So I think being able to deploy this to the edge or level of compute that can analyze everything that the sensors are collecting, and then being able to capture and store and anonymize perhaps only the key bits of information which are relevant to you as an organization, which you either want to capture or you're allowed to capture. It keeps you safe as an organization, and it ensures that from an individual point of view that you're not being invaded upon, perhaps from a privacy point of view. So there's a couple of examples.
Yeah. Is there any security benefits with edge computing that is, makes it safer, I guess, in a sense, than an alternative solution?
Well, if you're transmitting data, as we said earlier, from endpoint to endpoint, of which you're not in control of, then yes. And particularly if you're storing it in a data center or within a cloud, that has some risk associated to it, which is outside of your direct control. So if you really want to ensure that your data is maintained and data sovereignty, if you like, is encapsulated, then yes, storing it locally enables you to have control over that.
Another example I really like with IoT, it's been around for a while, but we've seen it in TV ads for connecting technology is field to fork. This great experience of how do we get higher quality produce to our plates for healthier living. So better for agriculture and better for us. So sensors in a field of corn or a field of cabbages or a field of carrots, anything at all, can quite often be able to sense the weather. So how a farmer manages the crop from seed right through to when it's harvested, right through to the logistics of getting that crop either into industry to be manufactured or produced into a variant, or in its whole form, right through to a restaurant, to a wholesale food provider, to a retail store. We're seeing Internet of Things be able to connect that whole process from forecasting the weather and sensing the soil performance, right through to logistics, cooling, to cooling in transport, the time it's taken for transport, even blockchain tracking of the produce, right through to the cooling and the lifetime on the shelf. So the Internet of Things in the sensors and the compute right through that process has really been advantageous for that field to fork life cycle for us.
Oh, that's great. Are there any other examples on edge computing IoT that you guys want to touch on?
Well, we're seeing a big rise in smart cities. And when you look at a city as an entity and everything that's going on within it, it's hugely complex. When you look at waste management, when you look at public transportation, do I need to understand that a bus stops at a particular stop every half an hour, or do I walk to that stop and it knows I'm there and I'm going to get a bus routed to me and I know that I've got no more than a 5-minute wait time. From an energy efficiency point of view, or even from a safety perspective, where are we seeing perhaps accidents occurring on the road, and how are we going to manage our traffic systems to avoid that in the future, or even just from an efficiency point of view, how do we best route our traffic around the cities? So I think from a smart city perspective, we're going to see some, we already have large deployments today. We're going to see that continue. And then when you think about that city as a concept, and you can apply that to many different sectors and industries from airport management, or even if you're going to a sporting event, and you're walking in there, what's the most efficient way for you to get to your seat? Well, that could change event by event, or crowds and timing. So actively routing people the most optimum way for you to have that best experience, we're going to see that being adopted very broadly. Yeah.
Yeah, I think I heard an example recently about evacuation plans, even, and like having a system for your phone that is able to basically monitor the cars leaving a city and being able to communicate
exactly
effectively. It's awesome.
Or even in buildings, what is in buildings at the minute, evacuation is quite binary. It's quite you hit a fire alarm and you get out. But there's legislation on the way that is driving that to be not so binary, where it guides people to leave in the most safe route out of the building. So if you're on upper floors, you might stay there for safety. If you're in the underground car park, you might be guided out. But a building can have a much more sophisticated evacuation plan for any kind of fire or terrorist or threat risk.
I'm going to throw a curveball. When we talk about security, is there a way to disable the device in time? What if the fire gets too big and it ruins the edge computer?
That's a good question. From an infrastructure point of view, there are ways of protecting hardware. So there are ways of protecting heat around hardware. You're at the mercy of the connectivity ultimately, and money can solve a lot of problems. So you can all of the hard wiring getting to that piece of infrastructure can be protected. And as we evolve through time, the cost of new technology, shielded cabling becomes less and less. So can it be done? Yes. Is it within the affordability of that particular construction project? It depends.
Yeah, for sure. All right, awesome. Thanks, guys. Ed, appreciate you being here. Ryan, as always, thank you. And thank you all for listening to the Edge Tech Podcast. I'm David Kosloski. Please make sure to like, share, subscribe, comment if you enjoyed this podcast. It helps us out a lot. And thank you so much for watching. Take care.